I know I haven't streamed in a little bit. I've been hooked on WoW. I'm gonna do a little bit today, but it's more of like conceptualizing and next steps. So I don't know if you would call it like an epiphany, just like one of those things where like you'll think about something for a while and then something will snap in place in your head. I think that I can get a much faster procedural generation going with an alternate proc gen scheme. And the idea of that scheme would be, I guess, sector based proc gen. So the way I'm doing my proc gen right now is you scan a coordinate space, and it's an exhaustive scan. So you're scanning the area around the player in the universe, every single coordinate space, and you're figuring out what goes in those coordinate spaces based on the specific coordinate space. But if we say changed it so that the lower we have nested coordinates, right? You have a universe XYZ and then a system XYZ currently. Currently, the lower coordinate corresponds to your possible star locations. And so that's what we're scanning, right? We scan the possible star locations looking for anything that passes a certain threshold, but that requires us to exhaustively scan the entire space. So say we're doing a 40 radius scan, that's 80 cubed. We can go ahead and do some quick math, which means that to scan that coordinate space, we have to do 512,000 loop iterations. That's a lot. And obviously, it was hitching the application when I was doing that, which is why I moved to doing these calculations asynchronously. Because if I didn't do that, and I did that many loops, there would be like a visible pause in the rendering of the game itself before it would pick back up, because it just takes too long to do that many loops. It's too much. What I've realized is if instead of using each of those lower coordinate spaces as a single star's location, we can instead use them as a sector of stars. So let's say instead of scanning a 40 radius, we want to do sectors, and we want to scan a radius around the player's current sector of 2 to the third, which means 8 loops, 8 external loops. And then what we would do for each of those sectors, rather than generating the stars on a single location seed, the sector itself would be responsible for generating a set of stars based on its seed. So let's say the sector we generate seeds for these 8, we generate our randomization core objects for these 8 places. And then we can take, say, like the density value from our seed of a given place, and we can use that to modify a randomized number of stars that will be generated in that space. So let's say we have a maximum of 1,000 stars per sector, or 10,000 stars per sector, and we're going to roll a random number between 1 and 10,000, and then we're going to modify that number by the density. So what that means is, let's say each one of the sectors generated the maximum number of stars that the sector can contain, the maximum number that we rolled. That would make each sector, that would turn this into 80,000 loops versus 510,000 that we were looking at before. This is a huge optimization, but this is the absolute maximum. This is if everything rolls max, every random value rolls max, the densities roll max. In reality, it's likely to be much smaller than that. So if we're rolling 10,000 and we didn't have any density changes, then you would expect roughly 5,000 per system. So that's only 40,000 loops. And then we modify it by per a combination of sectors. And then if you modify that by the densities, you're probably more likely looking at 20,000 loops. So 20,000 loops versus 510,000 loops is a huge, huge optimization advantage, and it comes with other advantages as well. Being able to control the individual sector densities with various types of things, like we could use, for instance, a top-down texture view, or a 3D texture view, where the texture itself is a grayscale spiral galaxy, and we could use that to control our densities. And then in these spiral arms that are white in that texture that we're sampling from to determine densities, you would have a high concentration of stars, and in the places where it's black, you would have a low concentration of stars. And then when you look at it from a distance, all of a sudden it looks like a spiral galaxy. So that's one thing that I'm looking to do in the next few months. Probably that'll be the first thing I start working on, because that's a huge optimization. We can make it stream in stars much faster. We can make it more responsive. I think we can make it look better. The other thing is Star Citizen actually announced that they're going to add different modes for the ships. And I really like this idea. Because, like, ideally you want dogfighting at slow speeds because it's more engaging, and travel at high speeds. So adding travel and combat modes to the ships, to the ship model, is another thing that I want to do. And another thing that I'm going to be looking into heavily is different types of proc-gen paradigms that I can use to kind of optimize this. I will be back in just a minute. Gotta go hit the restroom real quick, and then I will return. Hello, Ted. Alright, I'm back. So, there are a few other examples that I wasn't talking about earlier, or that I didn't mention earlier, with changing the ProcGen methodology here. I would call it more of like a top-down approach rather than a bottom-up approach, which is what I've got now. Rather than scanning every coordinate space to figure out where the stars are, we'll divide the space up into larger chunks and have each chunk decide from the top of the chunk how many stars it's going to contain and where those stars will be. This gives us a lot of useful abilities, and I'm hoping will enable me to do a few different things. Not the least of which would be to keep track of all the local star systems without having to interact with the Niagara particle system. Because if each chunk knows the stars in the chunk, then we can go ahead and generate all that data up front, and I'll just have it in hand, and I won't have to go to the Niagara particle system for it, and I think that'll be very beneficial to the game as a whole, and also speeding it up. So you can see, we'll go ahead and start this up, right? Obviously there's a bunch of logs and shit, but like you can kind of see, like it takes time to load these things in because of how much has to be scanned. And when I do it the other way, we'll be reducing the amount we scan by like more than 10 times, which should be a huge optimization. We can continue to utilize it with the asynchronous stuff. You may be able to tell, like, I still obviously need to work on the textures itself for the nebula cubes, and I'm not resetting the boundary textures when you cross universe coordinate boundaries, which needs to happen. But I did solve the issue with the blending. So I'm going to go fast, and that means we will escape from our stars, which is one of the problems I'm hoping to alleviate with the top-down idea. Because I could generate the stars, if I can generate the stars much faster, it'll be much harder to outrun the star system you're in. So you see the flip there, that is because, okay, so I actually want to restart this so that I can travel only on x-axis. The flip there is because I'm not properly resetting the textures on the edges of the coordinate space. But what it does do, wait, what just happened? Did I just, okay, yeah, we can do this. So keep going this way. So you see the local X decrementing here, 400, 400, 300. So as this decrements and moves into the negatives, we're going to start shifting to another nebula sphere. One of the other things about the sector-based rendering is that each sector can be responsible for its skybox, basically. And it won't be at the universe level, it'll be at the sector level, which means that I'll get faster transitions, and I'm going to have to figure this out. Like, I'm not sure this is going to be the way I do it, but this is an example of how I could do it, and you can kind of see transitioning happening here as the other skybox becomes more and more opaque, and the one that we were in becomes more and more transparent. And by the time I hit 499, the original one would be completely invisible. And at that point is where you would be swapping out the textures. You would basically move the texture into the next box and then generate a new texture for the next box, which is why you see this. But I really wanted to just get the like fade working right. And it does seem to be. So like the transition in between works, but the transition at the boundaries of the universe coordinates isn't actually set up yet. So this is another thing I'll be looking into. I'll probably put this on hold till I do a implementation of the new proc-gen paradigm that I outlined earlier. I think that's next on the list. I want to try and get this thing as fast and as optimized as possible because it's kind of like the core of the map of the game. The material textures here need work. Like there's holes you can see that shouldn't be happening. So that needs some work, but that's more like aesthetic stuff. I'm more looking for like functionality here, and the functionality seems valid. So that's good. Except that I'm getting like tearing at the top, at the poles, which it shouldn't be doing. But anyway, so this is just a quick update. Also, I'm still going to be working on this project. I'm also playing WoW for, I don't know, some amount of time. Probably till we get Gladiator. So I'll be doing that quite a bit as well. There will probably be less streams on this project, but there are ideas that I have in store for the project that I think will be good, and I think will be interesting to implement. As far as for today, that's pretty much all I wanted to say. It's just a quick stream update on this project. I'm not done with it. I haven't put it down. I'm just battling that WoW addiction currently in Wrath of the Lich King Classic. So I'm gonna give myself some time to burn out on that before I devote a ton of time to this. But I will be doing a few here and there. And that's it.